Let's take a step-by-step look at this important plot, which explains the saturation and desaturation of a model tissue. As usual, we have one axis to the right and one to the top. The x-axis, i.e., the one to the right, represents the ambient pressure. The y-axis to the top represents the inert gas pressure in the tissue. The graph starts at 0 bar. However, since we are not diving there, we need a reference line. The blue line represents the surface. Without specific values, it can be at sea level or in the mountains. This field is now separated by a yellow line. At this line, the ambient pressure is equal to the inert gas pressure in the tissue. Below this is another gray line. Here, the inert gas pressure in the tissue is the same as that in the breathing gas. The area below the yellow line is divided into two fields, one gray and one green. In the gas we breathe, gray would be the inert gas, usually nitrogen, and green would be what is not inert gas, primarily oxygen. In the gray field, the inert gas pressure in the environment, in the breathing gas, is greater than in the tissue. The tissue absorbs nitrogen and saturates until it has reached pressure equilibrium. When the ambient pressure then becomes lower, as you ascend, you pass through the sweet zone, the green triangle. Here, the tissue slowly begins to desaturate, very slowly. However, it is not yet supersaturated. Although the inert gas pressure in the tissue is higher than in the lungs, it is still below the ambient pressure. Only when you cross the yellow line and enter the yellow field is the tissue supersaturated. Here, the gas pressure in the tissue is higher than the ambient pressure, and only here can bubbles form.